Hey guys, so week 8, lesson 1, right? This is going to be very similar to the last lesson that we just did, the graphing radicals, the cube roots and all that kind of stuff, moving them around, seeing what they do. It's going to be the same exact thing, except now we're talking about exponential and logarithmic functions. At the beginning of the year, we did parent functions, right? And you got a glimpse into all of these things that we've been doing. Whenever I introduced that to all my students and we sketched the graphs and looked at their domain and range, I told them basically you're looking at what we're going to be doing the rest of Algebra 2, right? This is basically just a basis of, we're going to dive into all of these parent functions as we go, and that's basically what Algebra 2 is. So we're finally getting to these exponential and log functions. So without further ado, right, this is, again, it's going to be transformation, so it's going to be the same exact process, same exact idea as last time. If you're really good at transformation still, remember, if you don't have those transformation rules, make sure you're Googling, algebra transformation rules, and you'll get them all there. And, there's going to be nothing different. So just for a quick review, again, let's start with these, right? So up here, it looks like I have this 4 on the outside. So that's a vertical stretch, right? That's not writing properly. It's okay. Vertical stretch. And then we have and then what we're doing is we're adding 3 on the inside. So that's going to move to the left 3 units. And then what we're doing out here is we're subtracting 1 on the outside. And that's going to go down 1 unit. Right, down 1 unit. So over here, g of x, 1/2 times x minus 7 squared plus 2. Again, you just kind of go down the line here. So we have this 1/2 out here, and that's going to be a vertical compression. Then you have this minus 7 right here. That's going to be going to the right 7 units. And then what we have out here is a plus 2 on the outside. So that's going to go up 2 units. Right, nothing different there, nothing different. And then over here we have h of x. We have that negative out front. So that is going to reflect across the x-axis. Remember, if it's on the outside, it's affecting the y values, which means if your y values go from positive to negative, it's reflecting across the x-axis. And then we're adding 1 to the inside, so that's going to be going to the left 1 unit. So as we move on here, right, again, that's nothing new. We all know what that looks like. There's really nothing there. But for now, let's come down to this semi-new stuff, right? Again, you guys have seen these parent functions before, so it really shouldn't be too new to you guys. So let's go ahead and graph this parent function of exponential. So first of all, this is an exponential function. Exponential. So when I go ahead and graph it here, I'm gonna actually, this is pretty important. So what I'm gonna do here is graph it really quick, which it's gonna be really small on this side, and then it's gonna exponentially grow over here. So I want to kind of dive into, and we're gonna zoom in here literally to this function really quick, because this is important, right? This cross point of that y-axis, or you guys know it as a y-intercept. Right, that y-intercept, and actually I'm going to make this a different color because I need it to stand out. Let's use green. This y-intercept is always going to be at 0, 1. Always. Now, that's only for the parent function. That cross point will change depending on what transformations are being done to this thing. Right? If I move it to the right, then it's going to change, right? If I move it to the left, it's going to change. If I move it up, down, it's going to change. But for the parent function, it's always going to go through that 0, 1 point. Now, why is that? If I were to plug in here, okay, well, let's see what y equals when 2, and you plug in 0 for x. Well, hopefully you guys remember that anything to the 0 power, anything, doesn't matter what it is. It could be a billion to the 0 power. It could be -4 to the 0 power. Anything to that 0 power is going to equal 1. anything, right? So if you just have a base parent function of an exponential function, which means 2 to the x, 3 to the x, 4 to the x, 5 to the x, you know, it could go up to 100 to the x. Doesn't matter what that base is, as long as nothing else is being done to it, it's going to intercept the y-axis at 1. So it's going to go through the point 0, 1, right? Now, the next important point is at the x equals 1, right? So at x equals 1, that's up here. And, you know, my drawing may not be to scale right here, so bear with me. But whenever I plug in 1, y equals 2, and then plug in 1 for x, anything to the first power is going to be equal to whatever it is. 2 to the first power is 2. 3 to the first power would be 3. 5 to the first power would be 5. 100 to the first power would be 100. Doesn't matter how ugly that base gets. If you raise it to the first power, it's really like you're doing nothing at all, and you're just keeping what the base is equal to. So 2 to the first power would be 2. So this point right here would be 1, 2. Or in other words, for the parent function, for any basic exponential function out there, you're going to have two of these really important points. You're going to go through the y, you're going to have a y-intercept of 1, and at x equals 1, your y value is going to be equal to whatever the base is. Right, so that's going to be really important, and I wanted to make sure that I talked about that extensively before we moved on. Okay. Now the log function over here. So I'm not going to write out logarithmic, right? Log is right there. You see it. You can literally just call it log. That's fine. So we're going to get this graph here. And so log, if you guys remember, is the inverse function of exponential. So if you guys remember kind of what it looks like to be an inverse function, it's reflected across y equals x. So it kind of reflects diagonally. And you're going to see that here. So whenever I do this, right, it's going to be going really close to the y-axis here. It's going to cross, and then it's going to go this way. And if you remember, if you need a side-by-side here, the exponential function is doing this. See how it kind of reflects across this y equals x line? See that? So that means they're inverses of each other. Obviously, that's not a perfect drawing, but you know kind of what I mean there. Right, so let me erase this stuff really quick. So for those of you who do remember what inverse functions are, that you know this is exactly what this is. If you don't worry, you will get taught that again later. Right, so there's your log function. Now, obviously, if it is a perfect reflection across, then this point, yes, is going to be at 1, 0. Right, but that's really the only thing I would worry about is that intersecting at 1, 0. It has an x-intercept of 1. So remember, and you know what? I'm going to write this down. Remember, an exponential function has, we'll write it in pink here, y-intercept. And remember, this is just the parent function. These can move around. But the parent functions, y-intercept equals 1, and then the log function over here, the x-intercept. And I'm writing that now because I don't care. So y-intercept equals 1 over here, x-intercept equals 1 for a log function. And then the details of a log function really aren't that important. I'm not going to bore it with you guys. Okay. So without further ado, let's get into the transformations taking place. And this is going to take no time at all. We're just going to breeze through this. Okay. So let's get into this one. So basically, same thing as last time. We have see what transformations are taking place and then provide a quick sketch of the graph. And that's it. So I'm just going to worry about where these things are moving, provide a little quick sketch, and then we're all gravy, right? So f of x equals 2 to the x. So that 2 to the x, what's happening to it? Well, let's go in order. So let's go just up here. So on the inside of the parentheses, remember this is going to look a little bit different than what we're used to. What we're used to is having parentheses or a radical, something to provide us with, hey, this is happening on the inside, and then what's happening on the outside, right? Happening on the inside, happening on the outside. It's the same thing, except now we got to look at kind of whether it's small or not, right? Whether it's in that exponent or not. If it's in the exponent, think of that as being in the parentheses. If it's not in the exponent, think of that as being outside the parentheses, right? We don't have actual parentheses now or actual radicals to tell us. So basically, if it's small, it's inside. If it's big, it's outside, right? So what we have first to start is this plus 5 on the inside. Now, that's easy, right? We know what if it's happening on the inside, it's going left or right, and then it's always kind of opposite of what you think. So if we're adding 5, then we're going left 5 units. And then here we're going down, I'm sorry, we're subtracting 1, so therefore we are going down 1 unit. Now again, we'll sketch a quick parent function. That looks horrible. There we go. So a quick parent function would be this guy right here, intersecting at 0, 1, y-intercept at 1. And what we're going to do here is we're going to shift that y-intercept according to what we've got written over here, right? We're going to shift this guy left 5 units and down 1 unit. So let's go ahead and do that. I'm going to zoom in over here. So I'm going to go left 5 units, so 1, 2, 3, 4, 5, and I've got to go down this whole unit. Sorry, it's a little not to scale, but remember that's at 0, 1, so if I want to go down 1 unit, it's going to go down to the x-axis, so my unit is right here. This is my new y-intercept, or so to speak. So then it's got to go here, this new equation, this new function has got to go through and then up. Right, it's not really our y-intercept anymore, but that's our critical point there. That's kind of the point at which it starts to really rapidly increase. So that's all you do there. So let's go ahead and erase all that movement. And there you go. There's your new function, the green one. Right, we move that y-intercept to the left and down 1. So let's move on. Number 2 here. A little bit more things are going to happen here, but again, guys, it's the same exact process. So let's go ahead and single out these transformations that are happening, right? First, I've got this negative out front, and I'm going to actually circle that a little bit better. So I've got this negative right there out front. So that means I'm reflecting across the x-axis. So reflecting across x, right? I've got this 1/3 on the outside, so that means it's a vertical compression. Then I've got this -7 happening on the inside, so to speak, like air quotes. So remember, if it's on that exponent, then it's happening to x. It's on the inside, therefore I'm going to the right 7 units. That is horrible. There we go. Okay, so let's go ahead and apply that, right? So again, I'm going to write this grid here. I'm going to put the parent function right here. Remember, this is at 0, 1. So we can go ahead and apply these transformations now. So let's just start with that reflection across x. It's going to go from 0, 1 and reflect over here to 0, -1. So if that were the only transformation happening, it would just be a mirror image across that x value, right? But obviously that's not the only transformation happening. It's also being compressed, which we will apply after we move it this right 7 units down here. So I'm going to move this 7 units, 1, 2, 3, 4, 5, 6, 7. That's going to be my critical point. And then it becomes very simple. So first of all, let's kind of erase all of this stuff just to get rid of it here, so that we can make this transform thing look really neat. Move this over a little bit. And so this is just going to really become a graph that does this bit. And it's being vertically compressed, so it's not going to rise or in this case, fall as fast. So it's going to just kind of be more flat than our original one was, right? Okay. Then finally coming down here to the log function. So remember, this parent function, I'm actually going to draw it first. No, I'm not. I'm not going to draw it first. So let's just see what's happening to this. So again, we're back with our comfortable parentheses here. That makes our life a lot easier. Now we know exactly what's inside, what's outside. We don't got to worry about it, right? So let's start with this outside part. There's an 8 being multiplied. So we have a vertical stretch by a factor of 8, right? So that just means it's going to be a little bit taller. It's going to increase, decrease a little bit faster. And that's about it. So, and then we've got this -4 on the inside. So that means I'm going to the right 4 units. Then I've got this +3 on the outside. That means I'm going up 3 units. That's all I'm doing there. So let's draw this out. Log function, remember, goes just like this. Remember, it has an x-intercept of 1, so it goes through the point 1, 0. And then I'm going to do exactly these steps over here. So a vertical stretch, I'll apply that to the graph. I'm going to go right 4 units, so 1, 2, 3, 4. Then I'm going to go up 3 units, 1, 2, 3. That's not to scale at all, but it's okay. All right, so that's going to be kind of where it starts to really panel to the right. So now let's draw it. So it's going to go all the way from here. And remember, it vertically stretches, so when it goes through there, it's still going to go very tall, right? It's not going to really flatten out at all. It's going to stay really tall, but it's going to start moving to the right because I've vertically stretched it. Right, so there you go. Right, not too bad. Not too bad. Remember, all those transformation rules stay the same no matter what function you're talking about. It doesn't matter what function you're talking about. Those transformation rules stay the exact same, and you guys are pretty familiar with that. So just keep doing what you're doing. If you have any questions, make sure to let us know. Otherwise, hope you guys have a great week.